Good day and good evening, everyone. My name is Keith Wiebe, and I'm a Senior Research Fellow at the International Food Policy Research Institute, IFPRI, and lead of the CGIAR Initiative on Foresight. It's my pleasure to welcome you to today's webinar on what does climate change mean for the future of agriculture, insights from the impact modeling system. This is the first in a series of webinars on IFPRI modeling systems, informing future pathways and priorities for agri-food systems. These are co-organized by IFPRI and the CGIAR Foresight Initiative, and are intended to provide an overview of some of the tools we use to look at various aspects of the future of food systems. Today's webinar will focus on how the impact modeling system can be used to analyze climate change impacts on agri-food systems, how those impacts may vary across locations and over time in the coming decades, and how those results can inform decisions about policies and investments today. We have a great program and a great group of speakers today, and I'll go ahead and introduce them all right up front. First, we are joined by Aditi Mukherjee, who is Director of the Climate Change Adaptation and Mitigation Impact Action Platform of the CGIAR, based in Nairobi, and also very active in the Intergovernmental Panel on Climate Change, or IPCC. Aditi will help set the stage with a brief overview of climate change and the challenges it poses for agriculture and food systems. Aditi will be followed by our two presenters today, Tim Thomas and Faika Hartley. Tim is a Senior Research Fellow in the Foresight and Policy Modeling Unit at IFPRI, based in Washington, D.C., and Faika is a scientist in the same unit, based in Cape Town, South Africa. Tim and Faika's presentation will focus on exploring climate change and its impacts on agriculture with examples from Eastern and Southern Africa. Finally, Inga Jacobs-Mata will share some insights on how this kind of an analysis can help inform decision-making. Inga is Director of Water, Growth and Inclusion at the International Water Management Institute, IMI, based in Pretoria, and lead of the CGIAR Regional Initiative on Eastern and Southern Africa, also known as Ukama Ustawi. Before I hand it over to Aditi, a few quick notes on how we will proceed. About half of our session today will be allocated for our speakers, and the other half for questions and answers. Please feel free to send your questions via the Q&A window at any time during the webinar. After we've heard from the speakers, we'll do our best to answer as many of your questions as time permits. When you do submit your question, please let us know who you are, where you are from, and what organization you are affiliated with, if that's applicable. Finally, we are recording today's webinar and will make it available on our website shortly after the live event. With that, over to you, Aditi.
Thank you, Keith, and thank you, and congratulations for the launch of a new webinar series, starting with a topic that's extremely relevant to what we do at the CGIAR. So for many of us who have been in this profession for a while now, we were taught to think of climate change that will happen sometime in the future, but we all realize now that future is today, that future is now. So climate change is something that we are already in it. We are in a 1.2 degree warmer world, and the climate impacts are already apparent for all of us to see. And this is no longer a thing that you would only experience if you are in the global south, but irrespective of where we are in the world, I am pretty sure all of us have experienced several events that have been only caused because of the excess greenhouse gas emissions that we have pumped into the atmosphere since the last 150 years. So I thought something that I experienced just 3 weeks ago. I was in Kolkata, from where I am from in India, and in very early April, we had a heat wave. Such was the unprecedented nature of the heat wave that the public schools were closed. Right around that time, I was traveling back to Nairobi, where I'm based, as Keith introduced me earlier. And it just so happened that that was also the weekend when Dubai got flooded. I mean, they received rainfall in 24 hours that they normally would receive in 1.5 years. And right somehow, then when I made it back to Nairobi, Nairobi was flooded as well, and all the public schools were again closed. So that all happened within a few days in all parts of the world, from Asia to Africa. And studies have now shown that all these 3 events, for example, that happened just in April, would not have happened if there were no greenhouse gas emission, excess greenhouse gas emissions, or climate change. So all these three events had very clear climate attribution. So, which makes it, I think, a particularly difficult topic for the agriculture sector, because agriculture is also the most climate exposed sector. This is the sector that totally depends, largely depends on how the weather patterns are. I mean, not so many. Not many professions or occupations are as climate exposed as I think all our audience really knows. So we already know, and this is from the IPCC AR6 assessment, that we have shown with high confidence that 3/4 of the global harvested land experienced drought-related agricultural losses between 1983 to 2009. And many of these droughts are made more likely due to climate change. So there is an attribution. I think one of the novelties of AR6 assessment was that we were not only talking about climate variability, but actually climate change with attribution to the excess greenhouse gas emission. And in the agriculture, we also saw production losses of 9 to 10% during the years when with extreme weather events. So I think what it means for our future is a very critical topic for the CGIAR, because we work in the global south with the smallholder producers. So I think it's absolutely central to what we do. And we do need to know about the future impacts at disaggregated enough scale for us to take decisions on adaptation. But we also need to know how well will our current adaptation work in a future warmer world. So a lot of our investment in the CGIAR is around how do smallholder producers, farmers, livestock, ranchers, and small-scale fisher folks actually adapt to the warmer world. And it's critically important to know how warm or what are the impacts going to be. So I think that is precisely the topic for today's webinar. And I am really, like the rest of you, really looking forward to hearing and learning more about those impacts. And I'm particularly interested in the so what question. So what can we do that makes adapting to a very warmer world possible, and we are actually effective in those endeavors that we are putting together. So with that, and thank you, and back to you, Keith.
Thank you very much, Aditya, for setting the stage like that. Tim, I'll turn it over now to you and then Fika for the presentation. Please go ahead.
All right, thank you, Keith. And Aditi gave a great introduction and lead-in to our presentation. So we're going to explore the ways in which our modeling system is helpful in understanding the impact of climate change on agriculture in Africa. Now I'm going to wait for the slides to appear. There we go. And we're on 2 slides from there, please. One more slide. There we go. Thank you. So here we just show Aditi's exact point. Climate change is already taking place, and these maps show how the temperature has changed in measurable ways, and the way precipitation has changed in measurable ways over the last 43 years, or the 43 years of this study. And you can see that the temperature has changed differentially. It's not the same in every location. You even see a small place where the temperature has maybe gotten slightly colder. But most places it's gotten warmer, and some places it's gotten a lot warmer. Similarly, for Africa, not as many places have been proven to have different rainfall due to climate change. However, much of Central Africa, you can see how that has gotten much drier. But there are other places that have gotten slightly wetter, as you can also see. So you can also expect how the changes in temperature and the changes in precipitation have already affected production and production patterns. Next slide, please. Since this is the first in a series of webinars, I wanted to introduce the models very briefly. And we basically are introducing 2 models. One is the impact model, which is a multi-market model, which is for the entire world and focuses on the agricultural sector. The other is RIAPA, which is a CGE model. It does country-level analysis, and it includes all sectors of the economy. Next slide, please. This is a picture showing the modeling system for impact, because today's talk focuses on the impact system. And in fact, today's talk is focusing on the biophysical side of things, leading in and feeding into the impact model, which is essentially a bioeconomic model. Next slide, please. And just to show that there's a lot of detail. In fact, there are some other modeling systems that do things similar to impact, but impact is one of the most geographically detailed modeling systems. We have, in the end, we have 320 units of analysis, which are the intersection of 159 countries with 154 major water basins. Next slide, please. All right, so we wanted to begin here showing the 5 major models that not only the impact modeling system uses, but modeling systems throughout the world, because these are from ISIMIP, which is a consortium of global modeling systems that study the impact of climate change. And you can see several things. First of all, how in each one of these climate models, climate change varies very much across space. The second thing that you can see is that there's great differences between the models. You can see, for example, that the UK model is very hot relative to some of the other models. For example, the MPI model, which has a big portion that is cold. So what this shows, though, is the uncertainty among climate scientists of how climate will evolve. And it points to the value of exploring scenarios through a complete modeling system, so one can understand not only the average expected change, but the range of changes that one might expect. Next slide, please. This is a similar slide, this time showing annual precipitation. And again, you can see that there are great differences between models and a great special differentiation. You can draw a few conclusions, however. We see, for example, that Southern Africa is drier in most of these models. And we can also see in most of the models that a band slightly north of the equator is wetter. Okay, next slide, please. So this is some of the detailed work that we do that goes into the impact system. We take the climate models and we run them through crop models, which help us understand the specific effect that climate will have on yield. And here you can see that red is lower yields from climate change. We call them hotspots, or I call them hotspots at least, and the green are improvements. So not every single area is going to have a negative consequence from climate change. Some areas are going to have positive consequences. And these are often because of warming up in areas that are slightly too cool right now for ideal cultivation. So the advantage of having this detailed information is it can help policymakers and donors focus on interventions that ultimately saves money, but it also ultimately helps the very people that we're trying to help, the farmers, adapt to climate change. Next slide, please. So this slide shows some of our more complex work that we've done. Instead of just looking at the average change from climate, we had thousands of climates, and we looked at these thousands of climates, and we looked at the distribution. And we tried to tell which areas were becoming riskier because they're likely to have more droughts and other low yield events from perhaps heat stress. And you can see that in low emissions, the impact, the change in low yield events, in extreme events that is very small. But when you get to the high emission scenario, almost all of Southern Africa, which was the focus of this particular study, almost all of Southern Africa is going to experience a much riskier future. And with that, I will turn the presentation over to my colleague, Faika Hartley.
Thanks, Tim. If we could have the next slide, please. So the table in this slide shows the projected change in production between 2020 and 2050 with and without climate change. So what this is essentially showing is how production changes based on assumptions around changes in productivity, changes in area, how global prices change, and of course how the change in global prices is influenced by changes in global demand and supply. So this is an output from the impact economic model. So what we can see from the table is that without the climate effect, which is illustrated in the third column of the table, we see that the highest rates of increase in production in the Eastern Southern African region is expected to come, or is expected for sorghum, vegetables, sweet potatoes, plantains, and wheat. So if we look at wheat specifically, wheat is expected to increase by 122% between 2020 and 2050. When we look at the climate change impacts, however, we see that climate change alters the production of many crops. So this is presented in columns 4 to 6 and 7 to 9, which shows the minimum, median, and maximum impacts from climate change for changes with and without CO2 fertilization. So the results show that in most cases, particularly if we're looking at the minimum impact, the impact of climate change will be negative across different types of crops. If we use wheat as an example again, we see that when we account for climate change and assume no CO2 fertilization, the impact on production could be as large as 12.3% less. So that means that instead of growing at 122% between 2020 and 2050, wheat production would only grow at less than 110%. Next slide, please. So in addition to the global impact model, which Tim described at the beginning of his presentation, IFPRI also has a smaller, more portable version of the impact model, and that's what we call the impact sum model. And this model can also be used for climate analysis. So impact sum is like impact in that the core economic model is very similar. We have the same equations, we use the same assumptions and elasticities within the model. And in most cases, impact sum pulls on data from impact, particularly for global price changes. How impact sum differs, however, is that it's very useful for country and regional analysis because it's a smaller version of the model. We're able to include country-specific information that we might not have for all of the different regions or countries in the world. So we can look at very specific questions using country-specific information. And it's also easier and faster to run, so we can run a larger number of scenarios. Next slide, please. So this slide shows an application of impact sum to Ethiopia, and this was done for the Ethiopian Country Climate and Development Report, which was published by the World Bank. So because of the increased flexibility of impact sum for single country analysis, in this study, we were able to look at the impact within 11 water basins, which is our sub-national level that we use for the analysis, as opposed to the standard 2 food production unit regions that are generally included in the impact sum model. So Ethiopia is an interesting case for our analysis because what we find in Ethiopia is that production is likely to increase under climate change at the national level. So this goes back to Tim's point where he made in which we don't see the same impacts across different countries within Eastern and Southern Africa, and Ethiopia is an example of where we might see an increase in production. When we investigate the impacts at the subnational level, we find that the level of detail becomes really important when you're looking at the impacts of climate change. So the figure on the right, for example, shows the change in crop production across a number of different crops at the 2 food production unit region level. And that shows that for wheat, for example, in both regions, which is the Horn of Africa and the Nile, and for both sets of climate scenarios that we look at, which is hot and dry and wet and warm, we see an increase in wheat production. However, when we look at the figure on the right, which provides more detail in terms of the subnational level, what we find is that particularly in the Horn of Africa, which is more affected by climate change, wheat production increases in some regions, but we do find regions where we also see a decrease in wheat production. Next slide, please. So the insights gained from climate analysis, both that presented here as well as others being done and undertaken within IFPRI, is necessary for decision making, particularly in the light of the uncertainty around the potential impact of climate change. So these insights can be used to inform specific sector policies in agriculture and can also be used to more broadly inform adaptation planning and the allocation of investment. These insights can also, especially when included as part of a broad analysis, be used to inform broader economy-wide decision making. So, for example, in South Africa, climate analysis has been used to inform the naturally determined contribution, as well as different adaptation strategies. But on a broader level, the analysis has also been used to better understand the exposure of, for example, the financial sector and central banking system to climate change risks. So there's a similar need for such analysis and information in the rest of the region, with detailed agricultural impact assessments becoming particularly more important given the dependence of so many countries on the agricultural sector. Next slide. So this presentation has provided some insights into the impact of climate change on agriculture in the Eastern and Southern African region, drawing on the findings from our impact analysis. It has focused primarily on the biophysical impacts while showing some of the implications for production. A future webinar will focus more on the economic aspects of the impact modeling system and the insights gained from this for the future of the agri-food system. Thank you.
Thank you very much, Tim and Fika. And I know it's a tremendous challenge to try and summarize such a large amount of work on such a big, complicated question in just a few minutes, but thank you for being very succinct in your overview. And in a moment, we'll come back to questions and you may have a chance to elaborate on some of those points. But first, we would like to hear from Inga Jacobs-Mata, who has joined us and has had experience using this kind of information in interacting with partners in the region. So Inga, we'd love to hear a bit about your experience doing that. Welcome, thanks, over to you.
Thanks so much, Keith, and good morning, good afternoon, good evening to everyone joining this webinar. I lead a wonderful initiative of CGIAR called Ukama Ustawi. It's a regional integrated initiative in Eastern Southern Africa. And the work by Tim Thomas, Sherwin Gabriel, and others has been a very useful tool in our engagements around policy support to our country governments that we work with. So in a nutshell, Ukama Ustawi is really about diversifying the maize mix system in Eastern Southern Africa. And these types of models have been really helpful for two reasons. I'll just share two examples with you. The first one is really how it has contributed to informing current policy support to governments. So what I have found quite helpful is how the use of the results of these models can help our team, our research team and partners support policymakers to understand the potential impacts of climate change on agricultural, economic, and also trade policies. So by simulating different policy scenarios, we are able to predict different outcomes related to, food security, poverty rates, economic growth, that can inform decision making. The second contribution is also looking at the economic impacts, right, of agricultural investments and technologies, and how the results can assist in strategic planning and resource allocation even. So one of the countries we've been working in for the past few years is Zambia, and there we've done an analysis where we know, as Tim also mentioned, Zambia is already experiencing the adverse effects of climate change, such as shifting planting seasons, lower yields, higher food insecurity, and with by looking at the different climate scenarios, we also are able to see both the direct impact on agriculture and different value chains, but also some of the more indirect or spillover effects from other sectors, climate impact on hydropower generation, for example. So this has been part of our initial info notes, briefings. It has informed some of our country policy dialogues in Zambia that has ultimately led and informed our work in Zambia to develop the National Framework for Weather, Water and Climate Services, for example. So that is a national policy strategy of in Zambia that we are directly contributing to at the moment. The second thing that I just wanted to briefly mention is how this informs future impact work. So something that we are doing at the moment is it's called the State of Region Report, and this is really for partners in East and Southern Africa to imagine what the future agri-food system would look like in our region and in countries, and also sort of reimagining the future that we want to see. So this is largely a qualitative participatory scenario development exercise, but this work has also helped contribute to it. So it helps us really sort of model, the impacts of these futures, so to speak. This is work that has just started now, and it's not only for the initiative. It's really looking at the collective of CGIAR as well as our partners in the region to say, are we really moving the dial when it comes to diversification in East and Southern Africa? Are we really sort of collectively making a difference? And so it's been really helpful thinking through some of the quantitative metrics around that. I'm happy to share some more information, but I think I will leave it at that, Keith, and really looking forward to what the audience questions and comments are on this. Thank you. Back to you.
Thank you very much, Inga. That was so interesting to hear, and it'll be really important also to hear feedback from the partners with whom you're working, because that can help inform and guide the analysis that will be more useful to specifically what they're looking for. So thanks very much to all of our speakers. Now we're going to have an opportunity to hear questions that are on our audience's mind, and a reminder to all of our listeners, please do submit your questions via the Q&A window in Zoom, and then our colleagues will read those out. And if I could invite all of the speakers to join me now on the screen. And Eleanor and Evgenia, please go ahead with any questions that you've seen so far.
Thank you, Keith. So we had two questions about the same thing, essentially, saying your presentation focused mostly on Africa. Have any such analysis been done on Asia, particularly on South and Southeast Asia?
Tim, let's hand that one over to you.
Great, thank you. So I didn't distinguish terribly well when one study ended and another study began. So let me spell out a more general picture. Inside impact, we have the entire world. So every slide that I showed, except for the very last one on extreme events, that is all embedded within the impact system. And so we have data on all those places throughout the world. And I'm variously assembling reports on places throughout the world. But I only have one already published for Eastern and Southern Africa. But on the extreme event side of things, we just recently acquired the data set for Asia. And so we've started work on an analysis for Papua New Guinea. And I believe we have plans to start one for Nepal pretty soon. So we do have some things in the works, and we have capability of expanding, but there's a lot of computer time involved in generating these results for extreme events, because we have to do a whole lot more modeling work to get them.
Thanks, Tim. And Aditi, you also had a comment to add on that?
Yeah, for many of the physical changes due to climate change, I would actually also recommend people to look up the IPCC's AR6 interactive atlas. That atlas really has, you can downscale it to a really low level and see what some of the main climate impact drivers, as they call it, which is like hazards like, extreme temperatures, extreme precipitation, all of it you can see for different levels of warming, 1.5, 2, or 3-degree world. So that's a really nice, one of the most used interactive feature that the IPCC came up with, the AR6, is this interactive atlas. So I would also welcome all of you to basically look at that. That was derived using CMIP, which is an ensemble model of several thousands of these models, climate models. Yeah, that's what. So, Keith, thank you.
Thank you, Aditi. Evgenia, what do we have next?
Yes, we have a question from a colleague from Wageningen University. Impact also projects crop demand in the future, taking into account climate change. When accounting for future climate change impact, grain per capita consumption tends to decrease in Africa. I'm curious about the reasons behind these results. And I think this can be taken by either Tim or Faika.
Okay. Tim,
So
a question about impact and demand.
Yeah.
You want to take that one?
Well, I want to give a teaser that this will be covered in, I think, the third webinar in the series, when we get more into the details of the model. But, we have, apologize for economic speak, but we have elasticities built into the model that reflect changes in consumer demand that largely reflects changes in expected income in the future. And we know that diets tend to shift a little bit out of the cereals and into other foods, in particular the proteins, meats also, livestock products and whatnot. So we sort of expect the shifting to take place. Did I get that? All aspects of the question there? I think I got it.
Thanks, Tim. Faika, would you like to add anything on that?
No, I'm good. I'm happy.
Okay, very good. Good. I see more questions coming in. So, Evgenia, please keep them coming.
Are there studies comparing global results from initiatives like GGCMI and MIP, to more regional studies that use diverse management practices and quantify uncertainty?
Tim, this sounds like another one for you. I'm gonna start with you, but invite the others to jump in at any point if they'd like.
I'm hoping there's someone slightly more knowledgeable than me, because I'm not really aware of comparisons to regional studies that don't use some of the global climate models. But we didn't really make it clear, but inside impact, there are adaptations built in. So we have a number of sort of natural adaptations. What we don't have, we sort of have what you'd consider most likely scenario for farmers and policymakers to choose. We don't actually model, well, what if policymakers had a stronger intervention of greater investment than we would expect is business as usual. So that probably doesn't fully answer the question. Maybe somebody else has something to add to that.
So I see that the questioner has elaborated. The reason for asking is that GGCMI and EasyMIP use standardized protocols and so forth. So Those are essential for consistency and comparability across studies. Let's see. Regional studies often incorporate a wider range of local management practices. Yeah, I mean, let me, if I could just jump in as well. There's a trade-off here between global analyses where you're trying to do things which are consistent but also constrained by data that are available more widely, with regional analyses that can look in more detail and depth. And that's sort of analogous to as FICA was mentioning, even in impact on the economic modeling side, there's a global version, but there's also a country version that allows us, it allows us to go into greater detail when more data are available and when more specific types of questions may be interesting to a particular country. Inga, would you like to add, please?
Yes, Keith. I mean, just to add, these are not mutually exclusive. I don't think so. So having regionally specific data or nationally specific data is really helpful for the granularity. And models like Impact and RIAPA help with the sort of the regional analysis, or comparative studies with global other regions, for example. So I find the use of tools like this, especially in the beginning of policy engagement, to be really helpful. They are conversation starters. They're tools to facilitate engagement with decision makers, and also to help with that engagement at the country level between nationally specific data and models like this. So I just wanted to add that. Thanks.
That's great. Thanks. That's very important. Yeah. Good. Thank you. Evgenia, back to you.
Yes, so there is a question and a little bit of a comment. The person asking, thanks for the presentation, and asks, how do you account for the role of domestic or international trade in your model? For instance, a drought in allocation will lead to import crops from other locations. The following year, these other locations will have to grow more to compensate for the exports done in the year prior. There is a nascent literature on this topic that I'm part of. The person says, thank you. So please comment on this.
Great. Thank you. Tim, I'll start with you again.
Yeah, I don't mind answering, but I suspect that Faika is more knowledgeable, because she's run thousands and thousands of these in the Ethiopia simulations.
Thanks, Don. So in the excuse me, in the large global impact model, because what the model is doing is that it's solving at the global level, so it's solving all countries' production, so all countries' supply, in order to meet their specific demands. So what happens is that at a global level, the impact model would have total supply in the world equaling total supply and demand. So if there's a shortfall, particularly, for example, in one country because of a drought, you'll have more production taking place in another country, and the country with experiencing the drought would be importing. So the model does that endogenously on a sort of on a large scale, and that's the determinants of who's producing more relative to who's producing less is dependent on what happens to global prices, given the supply and demand, but also what's happening to the production costs within those particular countries that are producing. In the impact sim model, it works a little bit differently, because we're looking at a single country or a single region. What we're looking at is that we're looking at production within that particular region. So the rest, or let's say if in Ethiopia, we're looking at production in Ethiopia specifically. So if there's a shortfall in production because of a drought, what we assume in the impact sim model is that they are able to import the crops that are needed from the rest of the world. But we do include global prices from the impact model, so that there is some sort of, you could say, control on how much supply is available in order to be imported. I hope that answers the question.
Yeah, and let me jump in just for a second to piggyback on your point about prices. So inside impact, when prices rise, we find an increase in malnutrition in countries during those years. So it's not that everybody's fine inside impact. We take account the fact that when prices rise, the poor in the country will be hungrier. So so that's important part to understand how detailed the impact model is.
Thank you, Vika and Tim. We've got a number of other questions. Evgenia?
Yes. So another colleague would like ask for clarification on what kind of data sets you're usually looking for to feed into your models other than temperature and precipitation. And specifically intrigued to know if plant pests and disease emergence in a warming world and thereby the impacts on crop yields are determined, which will also shape farmer management practices going forward. Who wants to talk about pest and disease?
Okay, I can jump in. Two-part answer on the pests and diseases side of things. One is that some of our team likes to think about using the no CO2 fertilization scenarios as sort of compensating for the pests and diseases that will rise. So that's one way of thinking about it. But more completely now, there are a number of institutions, of course, in the CG system, and some of our partners in particular have done some work on pests and diseases. But in basic impact, in the basic structure of impact, pests and diseases are not explicitly built into the system, except through the growth rates. So whatever growth rate changes that climate change has already caused in countries, they transmit through the system through those implicit growth rates. So I guess actually there were three parts to that answer. So
Thanks, Tim. Evgenia, I wonder if we could jump down a little bit. Well, I see a couple of questions on collaboration.
I wanted to store them till the end because
okay, good. No, thanks very much for your interest, and we can come back to that. Just to try and cover a range of questions, I see here one on this, Inga, would be one really good to hear more from you. The biggest challenges you face when trying to communicate this sort of analysis to policymakers. They're busy people. They have lots of competing priorities and demands on their time. How do we communicate detail and nuance and high-level messages and so forth? What's your experience there?
Well, I can share the example of how I've worked with Tim and the team over the past 2 years, and I would say that the challenge is not so much in the specificity or the data, because what we do is it's really about how we compile this into very user-friendly policy briefs or info notes. So we are really not sharing all of this data with policymakers. It's about how short, succinct, and relevant to their policy needs it is. But I will say perhaps one of the challenges that we confront all the time is how quickly this data can be produced. So Tim and the team will always hear from me, and we need this data by tomorrow. There is a policy dialogue and a minister would like this information. So I guess the time issue is perhaps the challenge, not so much the level of detail in the content.
Mm-hmm. Yeah, always a challenge. Thank you. Evgenia, maybe you've had a chance to distill.
Yeah, if I can pick the question,
please.
There were a couple shorter ones, but they're interesting. So one colleague is asking how the climate change and another crisis like war or pandemic effect can be separate in your model, if at all. So if anybody could comment on this. Essentially speaking of other shocks.
Mm-hmm.
Well, I guess I can jump in.
Go ahead and give a try, and then I'm curious, Aditi, whether you have insights on how to bring multiple kinds of factors together. Tim, go ahead first.
So on the war side of things, I can point to the RIAPA model, which is the other model that's in this webinar series. and how that has been used to analyze the impact of the war with Ukraine on food and fertilizer and things like that. And now they have a series of 30 plus linked models that can be run in fairly rapid order to come up with this kind of analysis. I can say that perhaps, I don't know if FICA wants to jump in at all, but the impact sim system can also be used to some extent. It's a little more mobile. It can take shocks more easily than the big impact, which has a lot of countries in it, and therefore it's harder to parameterize and get to work. But the impact sim has capabilities in that regard.
Thanks, Tim. Aditi?
I don't really have much to add. I mean, in the world of climate change, very often we are actually trying to see the impact of climate change and what would have happened if there was no climate change. So that's the counterfactual world that the modelers are usually looking at. So it's not always that you also model impacts of other things, because you're really trying to look at the attribution of climate change.
Right.
I don't really have much to add beyond what Tim has said, because the problem really is how climate change is affecting. So yeah.
Right.
But I do see one question on the higher levels of warming, and I actually had the same question to the team.
Yeah.
Why RCP 8.5? Because RCP 8.5 is kind of almost out of the running now.
Yep.
I mean, one of the good things that emerged in the last 5-10 years of negotiation is that RCP 8.5 is out of the running because of the pledges we already have, so yeah.
Good.
Yeah.
Yes, and we do have an answer for that. Tim, is that the only RCP we look at?
That's right. So two-part answer again. First part is that while I showed RCP 8.5, we have RCP 7.0 and we have RCP 2.6 also embedded in impact. So we could show all those. But second point is that right now our model runs to 2050 and only 2050. And if you look at the greenhouse gas levels, the CO2 equivalents, whatever that you look at, out to 2050, there is not that big a difference between 8.5 and 7.0. It's after 2050 that they diverge greatly. So I don't feel, generally speaking, when I show 8.5, I don't feel we're doing anything wrong as long as we're going out to 2050 and not beyond.
Thanks, Tim. And thanks, Aditi, for flagging that as well. Evgenia?
We have a question about cost-benefit analysis in terms of climate adaptation and uncertainty. Implementing policies for very severe but rare events is expensive, and there is a trade-off between investing in policies known to marginally reduce poverty now versus investments in uncertain events. So essentially the question, how does the model take into account this cost-benefit analysis?
Great. I don't know if you want to answer it, Feike, or you want me to answer it?
Well, I'll go ahead and I'll try first. So basically, I mean, and I suppose this goes to the question that came earlier as well with regards to accounting for things like impacts from pandemics or war. What the impact model is, and the impact model is that it's a policy simulation that allows you to look at the impacts of different things. So you can develop scenarios where you can look at, for example, what could be the impact of a particular war within the model, provided that you include or develop that scenario with the appropriate parameters. And similarly, you could look at the impact of multiple events within the model by stacking these different scenarios that you've created in order to understand the impact of that. So when it comes to uncertainty, for example, one of the ways in which we handle this within the impact model and the impact sim model, and it's also why it's such a useful tool, particularly for climate change, is that we can run a large number of scenarios and look at the impacts of climate change under different climate conditions. Similarly, when we're thinking about climate adaptation, we can look at certain climate adaptation responses. So, for example, in the work that we did with the World Bank for Ethiopia, we looked at what would be the impact of increasing improved seeds or increasing the use of fertilizer, and how that would impact or how that would affect the results or the impacts of climate change. So those are things that we can look at within the model. There is a trade-off, and I suppose one of the differences between the impact model and the DIAPA model is that within the DIAPA model, you can look at, because as Tim said, it's an economy-wide model, whereas impact is a partial equilibrium agricultural model. So what you can look at when you look at in the DIAPA is you can look at different types of investments across different sectors and how they affect poverty, and you can do a cost-benefit analysis in that way. Whereas within the impact model, you're really only focusing on the agricultural sector. So within impact, you can look at the implications for poverty and, for example, Tim mentioned hunger and malnutrition as well, but you're really focusing only on the agricultural policy and not sort of the broader economy-wide impact. So you can look at trade-offs of different types of investments within agriculture, whereas within the DIAPA, you can look at trade-offs across different sectors, etc. Thanks.
Can I join in
Please
here?
go ahead.
Yes, a more non-technical answer, given that I don't work on either of the two models, but the consensus in the climate world today is that the cost of inaction is much more greater than the cost of action. So the traditional cost-benefit analysis of one particular action, whether it is beneficial or not, has become a little bit redundant in the climate discussion, partly because just the nature of the crisis and the fact that we have compound events. We are no longer talking about one discrete event happening here and there. We are talking of a slew of events that follow each other. So I don't know what the modeling world actually models compound events, because that's the world that we are looking at. Like we would have droughts followed by floods, etc., etc. So overall, in a large picture point of view, the consensus really is that the cost of inaction, climate inaction, be it in the mitigation or adaptation, is much higher than the cost of action. And I think there is a large consensus around that. And that's the way we should move to, instead of, focusing on event-wise cost-benefit analysis, because those are never really complete, and those are also have a lot of underlying assumptions.
Yeah. Thanks, Aditi. And not only compound sequentially, but also, I mean, multiple breadbasket failures at the same time, compounding the effects that you would have and those can be then either further exacerbated when you have conflict and other sorts of things that disrupt the existing systems. Okay, thanks. Tim, I see one specifically for you. This is from Maddie Schwarzkopf of the University of Copenhagen. You have discussed some sources of model uncertainties. How do you deal with that in crop yields from DSAT? There are many other crop models out there and have been quite a few studies on variation between them. So just a comment on model uncertainty, particularly on the crop modeling side, or question.
Yeah, that's a very good question. So we, while we have expertise in DSAT, we don't have to just use DSAT. Where our uncertainty comes in actually is by having thousands of climate models where we can simulate a full distribution of the future. Okay, that was very technical, but we basically have an idea, the spread of temperature and precipitation possibilities in the future. And we use those with the crop model. Actually, we build a crop yield emulator because it's faster to determine the yields. And so we could use any crop model. We could even use historical agricultural statistics, other things. We're not stuck with the DSAT, but we like DSAT because it seemed when we did an analysis compared to historical agricultural statistics, DSAT performed very well, and some of the other crop models we tried did not.
Thanks, Tim. And we're getting close to wrapping up the Q&A. I want to give each of the speakers a chance for some final comments. But before we do that, we had a couple of questions just expressing interest in collaboration. Thank you very much for your interest. And we are certainly interested in exploring those possibilities. So thanks for your interest, and please do contact us. And we look forward to talking with you further. Evgeny, I'm going to give you a chance to select one more question before we go back to the speakers.
I like the one on machine learning. What
Good.
are you anticipating with regard to machine learning applications in this area? And this was submitted by anonymous attendee. I hope it's not ChatGPT. Anyone?
Thanks, Evgenia. Yeah, anyone who'd like to comment on that?
All I can say is that we have some younger colleagues who are much more learned and much more flexible than I am. So we could definitely end up using machine learning and artificial intelligence on future applications. Potentially, I could see it now in particular in regard to land use change. Like right now, we're developing various models that help us look at land use change, shifting where crops shift. But I suspect that AI and machine learning will eventually help us do better than our models even.
Yeah, and I'll take the risk of commenting, certainly as a non-expert. I do think there's a lot that we can learn and use tools like that for, particularly in kind of understanding some of the factors that go into the model. I think there's still huge value to having what we call these structural models that explicitly look at relationships, precisely because then we can do experiments. We can learn a lot from AI, but it doesn't necessarily help us understand why did something happen. So it's part of a basket of tools that we certainly want to understand better to see how we can make best use of it. So thank you all for your comments and questions. At this point, I'd like to go back to our speakers and ask if we could, in reverse order, just invite each of you in a minute or less just to add any final comments or reflections that you may have from what you've heard today, starting with Inga, then Feike, Tim, and ending with Aditi.
Well, just on the machine learning, I mean, if it can help us with the processing time of getting the data out, from these models, then it's got my vote. ChatGPT or whichever platform has my vote. So Tim, please think about it. But in terms of just final words, we focus a lot on agri-food system transformation. So what would it take to transform a whole agri-food system in a region, in a country? And one of Tim's recent papers was quite was quite telling for me, because what it was saying is, in Southern Africa anyway, in up to 2050, the likelihood of maize continuing to be a dominant crop is still very real and will continue. And what we would need is very significant policy and investment interventions to change that. So something like that is quite a reality check for those of us working on diversification, in a region, and just the level of effort it would take to transform a food system. So yeah, I mean, this is great. This work does contribute, but it doesn't stop there, right? It needs that kind of next step interventions to really make the impact on the ground. Thanks, Keith.
Thank you, Inga. Feike, in 30 seconds or less, please.
Yeah, thanks. So I just want to thank all the speakers and the participants for interesting questions and interesting discussion. And I just sort of wanted to reiterate Aditi's point, which I think was so very clear, in that if we have no option but to do something, because the cost of inaction, that's a choice in itself, and the costs are much larger. So thanks.
Excellent. Thank you, Feike. Tim?
Great. I just thought that, again, to Didi's point and the original question, I was interpreting it. You can go either different ways with interpreting it. One way of interpreting it is, at some point, it's cheaper to do relief from a climate shock than it is to prevent a climate shock. For example, you could give irrigation to lots and lots and lots of people, but irrigation is very expensive in many places. And so that would eliminate droughts, or the impact of droughts in some places, but it might be easier and much cheaper just to have some kind of relief system set up.
All right, and I can see that's a potential topic for a whole new webinar. So let's
is.
leave that there as an open question. And Aditi, if you have a quick response on that or anything else, then we'll wrap up. Thanks. You're muted, Aditi.
Did I get muted? Yeah.
There you
So one of the things I think there is a real gap in this literature is that when it comes to impacts, we do know that impacts will happen, and the IPCC assessment shows that in aggregate, majority of the impacts are negative. There are only few places where you can expect some positive ones, and those ones don't really last. So overwhelming negative impacts of climate change. So in that, one of the big unanswered question is many of the investments that we have now, our adaptation investments, say, for example, irrigation, say, for example, high-yielding varieties of seeds, they are designed for a warming world of 1.2 degrees. How effective do they remain in 2-degree world, in a 3-degree world? And that's where we do not know enough. And this is where I think our modeling frameworks can also help us design those systems that remain still effective in a warmer world. And I think that would be a fantastic work that we can add to the global database on effectiveness of adaptation at higher levels of global warming. Back to
Thank you
you.
very much, Aditi. Yes, and with that, we've reached the end of the hour. I'd like to thank Aditi, Tim, Faika, and Inga, all of you, for your sharing your expertise and insights, and all of you who participated for joining with your questions and your interest. As mentioned, we'll make a recording of today's webinar available on the IFPRI website soon, and we invite you to visit IFPRI's website as well as that of the CGIAR Foresight Initiative to learn more about our work. Finally, please note that the next webinar in this series is coming up in June. We'll let you know the specific date as soon as possible. That will feature our colleagues Carl Poe and Amirta Aragi exploring the question, how do we prioritize agri-food systems policies and investments? Insights from the RIAPA modeling system. So we hope you'll be able to join us again for that webinar. Meanwhile, thanks again very much and goodbye for now. Have a good day.